Testing, testing, testing. So how is everybody today? How is chat today? How's chat? Well, seems like we don't have anybody responding to anything in chat at the moment. Perhaps people will in a few moments. The marks for test 3, or not, maybe the feedback emails, I don't think it's been made public on Avenue quite yet, although it will be shortly. Yep, so I expect once people start showing up that we'll probably have a bit of a gripe session about that, but we'll see how it goes. At any rate, given that it's 12:30, and given that you guys deserve your money's worth with respect to this lecture, let's continue on from where we left off with respect to machine learning in Python. So, coming to you live from Encino, California. No, just kidding. Yes. Classification. So, we're going to run through a couple of examples, following on from our classification example with respect to the various types of reptile and reptile-similar animals, I guess. Although I'm not sure salmons and pythons are particularly similar, but, you know. Anyway, we're going to now discuss some classification based on text. So we can perform this on more general types of data. We're going to be using the Natural Language Toolkit, which is a thing that you can get in Python. So, it's on JHub2. If you would like to install it, you would use any of the following command. The command here that's most appropriate to your particular computer installation pip3 python 3 sudo pip3 install numpy scipy scikit-learn, all of these sorts of things, although I think that most of those are Linux-based operations. If you were to Google it, I don't know, it might be in Anaconda. Let me just take a look here. Python, Natural Language Toolkit, Anaconda? Yes. So it's included in Anaconda as well. So as with all of the other things, just get Anaconda. Okay. Why is the total mark 60 rather than 70? Well, there were a couple of... Well, first of all, the total, presumably you're talking about the midterm, the total would be reflective of what it was out of, like, just the marks, not the bonus marks, I guess you could say. Or, I think. To be honest, Eric did that, but it's also, it turned out that the marks on the test were a little bit on the low side, so we decided to drop a couple of the test cases that nobody got. So that had the effect of boosting the numbers slightly, but there will be a slight inconsistency with the marks that the test was worth as stated on the test itself. But yes, hopefully that answers your question. I believe the bonus mark was worth the bonus question was worth 8 points, and 2 test cases were dropped, so that would bring us down from 70 to 60 as the thing it was out of. Yeah. So there you go. So anyway, I guess I'll just deal with these questions about the midterm as they come up. But feel free to ask. We are probably going to well exceed these slides in terms of the material we're covering. That's a bad way of phrasing it. I don't expect the slides to last this entire live stream. Let's put it that way. So please feel free to interrupt with any questions that you have about the midterm or the coming exam. That would be a good use of time. So, Natural Language Toolkit. The first thing that you have to do is, of course, obtain labeled data from your source. These data should include labels for each data element. Something that has been popular in recent years is using web scraping to obtain things like tweets or YouTube comments and stuff like that. And you have a thing called sentiment analysis. Oh, shoot, I should totally log out of Steam. So I don't get Steam notifications while I'm on stream. There we go. Sorry about that, folks. So, that's what some of your data sources might be for natural language. You can get really large databases or, large numbers of points of data relatively easy by scraping the internet and social media for them, if this is the type of research you're into. So the second thing you have to do is you need to construct feature vectors for the labeled data. For the Natural Language Toolkit, we will need a list. Each element in the list is a tuple containing 2 things. Number 1, a dictionary of features and values, and number 2, a label. So here's an example. Once again, going back to our animal example. We have our class of animal, we have name, features, and self.reptile, which indicates whether or not it is a reptile. that will be the label that we will be looking at in the grand scheme of things. I have to... Wait, jeez. Let me just see if there's a line at the end here. Sometimes it cuts off the lines at the end. I'm not sure why. It's because I insist on using events instead of Adobe, because, you know, Adobe is just... It's just a greedy memory pig. That's all that Adobe is. And there's no reason why a PDF display application should take as much memory as Adobe does. It's absolutely fantastically ridiculous. So I use events, or I use MooPDF, which is even lighter. But I don't know. I like events because it's a nice balance between being lighter on memory and being feature complete. MooPDF is missing some stuff. And that's MU PDF. Mu is in the Greek letter. Anyway, as in micro PDF. Anywho, so we have features as dictionary, which is just a simple function that converts all of the features to a dictionary. We initialize all of our animals, and then we create our feature set, which is a.features as dictionary, comma, a reptile for a in animals, where animals is a list of instantiated animal objects. This is, once again, list comprehension notation. So, the code on the previous slide produces the following array, which, as you can see, is reasonably similar to the dataset in terms of its presentation. It's just a bit more verbose because it has the label in each and every single dictionary. So this is what we're talking about when we say labeled data. We have the data, and we have the label. Cool? Let me know if there are any questions, guys. So, next, we want to follow the same thing that we've been doing so far. We want to divide our data into two sets, a training set and a testing set. The best practice is, of course, to split the data into two sets via a random process. So, once again, as I said in the previous lecture, if you just take like the first half and the second half, call one testing and the other training, that is a suboptimal manner in which to divide your data. The reason for that is that if there is any bias in the data that correlates to its position within the list of data or the collection of data, for example, if later entries tend to be not snakes in the case of our reptile data, then that's going to be basically you're going to train your machine learning algorithm into a bias, which generally speaking you don't want to do. Generally speaking, when you're doing this type of statistical work, you want to make sure things are as randomized as possible. And this also sort of feeds into the idea of having double-blind studies. So, again, it's useful to test your model to see how well it does, because without that, all you know is that you have a model, right? You want to be able to quantify the niceness of your fit. So, number 4, we train a classifier on the training data to develop a model. There are many different types of classifiers. However, we will be using a naive Bayes classifier. So, from nltk.classify, we import naive Bayes classifier. The training data is equal to feature sets in reverse, or no, sorry. that would be from 1 to -1. What does that actually do? That's interesting. So from the beginning to -1. Like, is that... Give me one moment, because that's interesting. Okay. Well, anyway. So we get our training data out of that statement, and then we invoke our class. We create our classifier object nltk.naiveBaseClassifier.train, and then we give it the training data as its argument. So once we've run the trainer, we can then learn a little bit about the model that it has developed. So if we invoke the method showMostInformativeFeatures and specify 5, it'll show you the 5 most informative features. This will be... So when it says features, it means features with respect to our feature vector. So since we have 1, 2, 3, 4, 5 features in our classifier, in our data, there are only 5 features that... Like, this is all of the features in order of how informative they are. So, legs is the most informative feature, which, you might be... I've discussed how I think the legs data is a little bit biased towards things that have legs previously. The next thing is scales. Scales apparently indicates reptile presence better than the rest of them, except for legs. Then whether or not it's cold-blooded, legs equals 0, and then egg laying. So there you go. Next, we can use the classifier to predict the labels for the testing data. We can run the classifier on a feature vector to see what it predicts. So we can create a list of predictions for t in the testing data, predictions.append classifier.classify t at 0. Then we print our predictions. So notice t at 0 refers to the feature vector. So we are feeding into the classify method a feature vector that lacks a label, whereas in the previous example we were feeding in the feature vector plus a label. Here we are absent the label. So next, of course, we need to measure what the accuracy of the predicted data is. So the natural language toolkit has some built-in methods for the calculating of the accuracy of these predictions. Basically, it's the number of correct predictions divided by the total number of predictions. So nltk.classify.accuracy of classifier and the testing data. So this is cool. That's how to do everything in a very automated way. So let's go on to a new topic, sentiment analysis. So I alluded to it a little bit previously, but this is a specific problem where you're trying to analyze whether or not a given piece of text expresses a happy or sad or angry or depressed sentiment, whether it's positive or negative. This is kind of like pushing the edge of machine learning. Like, this isn't very good yet, but we're working on it. So there are two basic approaches, or there are two fundamental approaches to sentiment analysis. The basic approach is where you basically generate a dictionary not necessarily in the Python sense, but you label all of the words, or a large number of the words in English, as being associated with a particular sentiment, and then you compute a score on that text based on the word usage in that text. So if the person uses the word great a lot, that is probably happy, although it could be sarcastic. And if a person is using disgusting a lot, that could be associated with negative feelings or also sarcasm. That's the way sarcasm works. Sarcasm can be associated with anything. So that's our basic approach. On top of that, we build our machine learning approach, which is to label pieces of text as having a particular sentiment, and then use a classifier, in order to predict sentiment. So this is our methodology, and of course, this may be familiar to you so far, as this might be the third or fourth time we've seen this slide. Number one, we obtain labeled data. Number two, we construct feature vectors for the labeled data. In this case, we're using natural language processing to construct feature vectors. Number three, we will divide the data into two sets, a training set and a testing set. Number four, we train a classifier on the training data to develop a model. Number five, we use the classifier to predict the labels for the testing data. And number six, we measure the accuracy of the predicted label on the testing data. So, with respect to natural language processing, our goal here is to take natural language, and natural language is a term used by computer scientists when they are referring to languages spoken by humans. It's perhaps somewhat idiosyncratic to computer science as a discipline, but it's how we distinguish between computer languages and spoken languages that exist in the human species, such as German, French, English, Mandarin, Korean, all of them, All of those are natural languages. So, we have a couple of processes in order to generate a feature vector from natural language. Number one, we have to tokenize the text, which is essentially to split it into a list of words. Sometimes you can go a little bit further than just stopping at the word level. Sometimes there are particular sentiments associated with phrases rather than words. You can tokenize according to clauses and phrases as well as words. And then there's also tagging. Once you have tokenized the text, then you have to tag them according to what their grammatical purpose is inside of the sentence. So are we dealing with nouns or verbs or adjectives, etc., 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 prepositions, etc. Next, we stem it. So we reduce the tokens to their root word so that we can identify recurrences of the same notation. So this is like the inverse of conjugation. This is the inverse operation of conjugation. A person, or, all of these things. So with respect to, working, worked, workable, all of these have work as a stem word, right? And the next thing we do is we remove common words with little meaning. So we remove things such as articles and prepositions and conjunctions, things of that nature, because they don't contribute anything necessarily meaningful in terms of sentiment analysis. If you were to try to have a algorithm that broke a sentence down into its logical equivalent, you would need to pay attention to things like prepositions and conjunctions. But with respect to sentiment analysis, all we're doing is we're trying to establish the general tenor of what's being said. So, once we have done all of this, we can construct a list of all processed tokens present in the sample text. For each sample, we can construct a feature vector indicating the number of times each word is present in the sample, and then we run classification algorithms on these feature vectors to try to group them together. So there is a software package called Vader, which is a sentiment analysis tool built into the Natural Language Toolkit. It is already trained to classify passages of English text on positive or negative sentiment. So, for example, the sentence, "If you're happy and you know it, clap your hands," has the following features: -0, neutral, 0.7, positive, 0.29, compound, 0.57. So this is overall a more positive than negative statement. And that's it. That's the last slide. Well, so that's it for the course. Kind of abrupt. Anyway, thank you very much for paying attention, for the 9 of you who are watching right now. That is it. Goodness. I guess it's not surprising what I'm doing at the moment. Anyway, so, good lord. So, with respect to the rest of this live stream, if anybody has any questions about anything at all, I would love to answer them. If you have any questions about the test that was, or the exam to be, I would love to answer them. If you have any examples of problems that you'd like to see solved, I would love to do that for you. The rest of the course is essentially exam review, so let's review. Anybody have any questions? Okay. One of the test cell cases in the midterm checks for a ticked attribute, which the test didn't ask us to define. Let me take a look then. Avenue. Yes, you said so before. Oh, yeah, that won't be... that won't actually have the... shoot. That won't have the test case in it, because that's the one that was distributed. Ah, crap. Let me think. I can't really... It's on the server right now, so... I need to be able to log into JHub, too, to be able to get the version of the test that has the hidden test case in it. So... Stopping and starting the stream is never really a good idea. So, I guess, Larry, if you could send me an email about that one, I will take care of taking a look at it off stream, because I really can't put this stream through the VPN. It's tough enough as it is, you know? Best not to mess with it. So, with respect to question 2, the virus game. Well, yeah, but not all of those marks were for the same thing, right? And, sorry, the comment is the 23 mark question was a yikes. Yes. Well, I've had a number of comments about it, saying things like 23 marks is, too many marks to get 23 or 0 on, but that's not really how it works, right? The test cases have been designed such that you get some part marks for partially correct solutions. However, and the way that the grades are actually structured in that question is that the methods that I asked you to write each had a certain number of marks associated with correct functionality of that method, which I thought would have been a fairly intuitive way. I thought that was intuitive enough that people would understand that was how the question was going, but apparently not. Apparently I need to be more specific the next time about how many marks each method is worth, so that people don't look at large numbers of marks and be like, but yeah. So, I'm tempted to say something like, with respect to the question 2 being considered kind of a mess by Moonstar. it's useful to understand that not every programming project that you're going to take on is specified down to the degree of a math problem, right? When you actually do something of reasonable size, there are going to be ambiguities, and it's useful to know that that's going to be a thing that can occur. That being said, nothing that was left ambiguous was made a test case of. So, and if anybody can demonstrate to me that a test case tested something that wasn't asked for in the question, they're free to send that my way. But in general, I don't know. I thought the marks came out all right for the test. Some people took a long time to write the test. If that one guy on Piazza, who says he wrote it for 10 hours, is telling the truth about that, then holy crap, that's a long time to be doing anything, especially programming work. I hope that they got a decent grade. So, yeah, no, it's, that being said, there is also a certain amount of scuttlebutt about people, oh, I misnamed this and I just realized it now, or, oh, it didn't, I got caught on a syntax error and I lost a bunch of marks. And with respect to that type of thing, I kind of have a limited degree of sympathy for that, because you were running this on Jupyter. If you'd actually, tried to run the code, you would have found that it had syntax errors. But even I took 3 or 4 hours and only got a 44 out of 60. Well, I guess it was a good test then. So, yeah, it was a hard test. It'll be fine. Your marks will work out. This was a hard test, but the first test was stupidly easy, so it'll balance out and everybody will get their grades. Yeah, okay. That's interesting, because that breaks the formula. So, if the average, I would be interested, everybody who's listening right now, if you could just tell me, how long the test took you, that would be very interesting to me. Because generally speaking, the calibration formula is that it should take 3 to 4 times as long as it takes either me or the TAs to write that test, right? So, if it took you 3 or 4 hours, then it would have hypothetically it took me a half hour, right? So, hope the exam will be easier. T3 was pretty damn hard, not gonna lie. Yeah, we'll see if St. Nicholas can't deliver you a Christmas present on that one. And I'm not saying that sarcastically. The final is not going to be as hard as T3, because this seems to have upset people. But yeah. I mean, it'll still be challenging, right? Took you 9 hours, excluding... Okay. I was shooting for 2, just so you know. Well, let's take a look at the wording then. So, question 2C, yeah? Wait, what? This is A9. Good lord. That's the one I'm looking for. So... So what about the wording was bad? Which question am I looking at here? Okay. Action. Takes two position objects. The algorithm always goes with the first cell it finds that is within a radius of 1 for both positions. If there is a cell at the first position and the second position, the cell at the first position attacks the cell at the second position. If the second position is not within range of any cell, the first cell is commanded to move to the second position. If the second position is within range of the first cell, change the mood of that cell to busy, and be sure to handle any exceptions. If the first position is not within range of a cell, the method does nothing regardless of the state of the second cell. So I can see, upon reading that, this first sentence perhaps was a bit trippy-uppy. The algorithm goes with the first cell it finds that is within a radius of 1 for both positions. Yeah, that could have been better worded. The intention was to say something along the lines of, you've got two position objects, the position 1 and position 2. The algorithm searches for cells within range of that, within a radius of within a range of 1 for both of those positions, and goes with the first cell that it finds. Okay, I agree that could have been a bit better worded. Right. Yeah, okay. Okay. I'll try to make sure there are none of those in the exam. I'll give it a read through. Any other points of contention in the test? Mercy? Mercy? He's asking for mercy. Oh my god. Well, like, despite the fact that it was a test that was long and hard, it was like I actually liked the way that the grades came out, so you know, I won't do another one of these virus game things with like just one screen entirely of test cases. Okay, so attack takes other of type cell as an argument. If not within the attack range of self, create an out-of-range exception. Otherwise, cell attacks with its whole population. This is its base attack value. The actual attack value is the base attack value minus the other cell's defense value. If the defense value is greater than the base attack value, reduce the attack defense by the base attack value. Otherwise, the defense value is reduced to 0. If the actual attack is greater than the other cell's population, the attack succeeds. Well, I mean, I guess it's sort of implicit in that the self is attacking other, right? So anywhere I make reference to the defending cell or the defending population, I'm referring to other, and sometimes I refer to other specifically. Whoop. But well, as I said, we're not gonna have another one of these. It'll be something perhaps a bit more. The descriptions won't be as long for what the methods do. It'll be compartmentalized a bit better. Are there any other questions? Well, if there are no other questions, comments, or concerns, I think I'll cut the stream off a little early. For next week, for our lecture, please ensure that you have some problems. It'll be exam review, so if you have questions, comments, problems, all of these types of things, that's what we'll be doing, considering we are now completely out of lecture material. So, thank you very much, folks. See you later.